name is Gregg Coleman,
Marshall Motley.
I'm Muhammad.
and today we're going to go over a problem of figuring out the yield moment, plastic moment, and the shape factor of a section.
So I was gonna start us off with going into part one. We're gonna find our section properties. In our section properties, we found the area of each piece in our area total. So in our area 1 and 2, we just wrote it once and found it to be 8 inches tall by 1/4 inch wide, which had left us with an area of 2 inches. We found the same area for our third piece, which was 2.125, and then after that, we commenced into our Y-bar to find our neutral axis. So whenever we found our Y-bar from our origin up here, we took our area times the centroid, the distance from our centroid to our origin, and then we added it for each piece. So we did 1, 2, and 3. So we've got all 3 of those here and divided it by the total area. Whenever we did that, we found our Y-bar at 2.81 inches. So we made our measurement here, and then we took our third step to a centroid. We solved for C by putting our total height minus our Y-bar, which was our 8 1/4 inches, minus our Y-bar of 2.81. That gave us our 5.44, which whenever we got into our inertia problem, we ended up solving for S later on with our C instead of our Y-bar because it was a larger number, where it ended up giving us a greater S value, so we ended up using it.
So next we're going to move into finding our little a for this section, for the top section and for the bottom section. So first off, we need to find and locate our plastic neutral axis, which is half of the area up top and half of the area below. So what we did was take the total area, which was 6.125, and divide that by 2, which we got 3.06. And so then after we got half of the area, then we figured out what our height is for this top section to figure out to get the half of the area of the top section. So then we got 3.06 divided by 0.5, which gave us our height of the top section. Next, we moved into finding the area of our top section, which was when we would take the height of our top section, multiply it by the base, and we combined the 2 legs, so that gave us a base of 0.5 inches. So then for the area of the top, we got 3.06. So now we need to go into finding our little a top. So then we took the height of the top section and divided that by 2 to get us the middle of that section, which was 3.06, and it just ended up being the same number as our area. So next, we moved to the bottom section, and we found our area of the bottom section, which was 0.5, which is just this section that we're working on right now. So we took the width of that section and multiplied it by the height of that section, which was 2.56, and we got that by taking the height minus our height of the top section that we already found. So then we got our area of the bottom section of just this section, and which was 1.28, and then we moved on to finding our little a of the bottom section, which we took our height and divided that by 2, and then we also added our bottom section to get, or the height of our bottom section to get little a of the bottom section, which was 1.53. So then we move on to finding our z, which is area of the top section times little a plus area of the bottom section times little a of the bottom section, all over your total area divided by 2, which we wrote up the numbers right there and divided it by our half of the total area, which we found earlier. So then we get 6.40 for that equation. So then we come up to find z, which is our distance, our little a, times your half the area plus your distance of the top section, your little a times the area, half the area as well, which eventually we got z is equal to 28.94. And now Mo is going to tell you how we figured out for the shape factor.
Next, so since we find the z and we have the s, we can find the shape factor, and we find that it's 3.5. Then we have to find the yielding moment, which equals to Fy, which we have before, and S, which we solved for, and we got 34.42. The next step is finding plastic moment, and it's also Fy times Z, which we both have. But in this case, we have to convert, and the final answer is 120.58 kiss per foot.
Other than that, thank you for your time.